Hello, this is Naz from NB Network Lessons. Hope you guys are doing okay. Once again, thank you so much for an amazing response. I really appreciate that from bottom of my heart. Keep following me. My objective is to basically educate you guys as much as I can. Right now, I'm giving lessons on networking, computer networking, algebra, and then circuit analysis. But I do plan on giving lessons on physics also, geometry also, trigonometry also, calculus also, and so forth as time permits. I do have a full-time job, but I do this on weekends and whenever I get time. So stick with me. Hopefully we all will learn and grow. Having said that, my today's topic is going to be inverse of a matrix. Algebra lesson number 31. Inverse of a matrix is, if you've watched my last lesson, I explained you matrix multiplication. Okay, so when you're solving for an equation where you have maybe 3 or 4 unknowns, 5 unknowns, it doesn't make any sense to solve the problem with substitution. So what you do is that you solve them by using the matrix. So that is what that is what the matrix does. So especially if you're a student of circuit analysis, you will see then when you have multiple KVLs, KCLs, you will use inverse of a matrix. So without any further ado, let's go ahead and dive in. So basically, A is a matrix, all right, and A raised to the power minus 1 is the inverse matrix, okay? And if you multiply both of them, that becomes identity matrix. So what is identity matrix? So let's say you have a 2 by 2 matrix, right? So if you have 2 by 2 matrix, and if you multiply A and A minus 1, the inverse, you will get something like this, okay? So that's your 2 by 2 identity matrix. So if you have, let's say, 4 by 4, then your identity matrix is basically in the diagonal, you will see all ones, okay? So you have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So this is the identity matrix for a 4 by 4. As you can see, this diagonal right here is ones. Same thing right here. So that is called identity matrix. Sometime in your exam, the professor will ask you to prove that you multiply A and inverse of A and see if you can get identity matrix. So let's go ahead and look at a formula. In order to calculate inverse of a matrix, this is the formula right here. So let's say you have identity matrix A, not identity, just a matrix A is equal to, let's say you have A, B, C, and D, okay? So A raised to the power minus 1 would be equal to A, B, C, D, and then you have minus 1, okay? Now let's go ahead and open it up. So if you use the formula is like this. 1 over AD minus BC, and then you have D minus B minus C minus A. So if you notice, what we have done is that we have 1 over A times D minus B times C, and then what we have done is that we have flipped A and D, okay? And as you can see right here, we have, let's see, sorry, this one right here is going to be minus B, this one, okay. So what we do is that we flipped, A takes D's position, D takes A's position, and then this, we just change the signs. That's exactly what I did. So A right here goes right here in this. D right here goes up right here. And then C and B stay at the same position, but we change their signs. Okay? So now you can use the formula to solve any problem. For example, we do, let's say we have A is equal to 2, 3, minus 1, and 2. Okay? They want you to find the inverse. Find inverse of this matrix. So pretty straightforward. You just basically, use this formula. So then it's going to be 1 over 4 plus 3. Okay. Actually, let me not skip any steps. Okay. 1 over A times D. Okay. And this A is 2. All right. D is 2. So that's going to be 2 times 2. All right. And that's going to be multiplied by, minus, you have B, C. B, in this case, if you look in right here, B is 3 and C is minus 1. So 3 multiplied by minus 1. And right here, I'm gonna basically do my, what I showed you in the formula. 2 and 2 are gonna flip, but in this case, 2 and 2 are same, so it doesn't really matter. So I put 2 and 2. In reality, if this was 3, 3 would go here and 2 would come down. And then what I do is that I keep these and I flip the sign. So minus 1 becomes plus 1 and this becomes minus 3. Okay? So then that is equal to 1 over 2 times 2, 4, minus 3 times minus 1, so makes it plus 3. And then you have 2 minus 3 plus 1 and 2. All right. If I expand this more, it becomes 1 over 7 because 1 plus over 4 plus 3. And then we have 2 minus 3 plus 1 and 2. Now you got to work on this. So I don't have enough room, but I will go ahead and erase this part right here. Okay. And finish the problem right here. So then what I do is that, let me write this again so that it's clear. I have 1 over 7, 2 minus 3, 1 and 2, right? So basically what we have to do is that we are multiplying 1 over 7 by each number in here. So then we get 2 over 7 minus 3 over 7, 1 over 7 and 2 over 7, all right? So this right here is my answer, okay? So this is basically inverse A minus 1 and A is 2, 3, minus 1, 2. This right here is A matrix and I took inverse of that and I got this. So in my next lecture, I will prove it to you that if we multiply A minus 1 matrix by A, we will get Z ones in diagonal. So stay tuned. I'm going to come back and show you that. Thank you so much for watching. If you like the contents, go ahead and give me a like and share as much as you can. Thank you.